Good morning, class. Today is what's the date? 8. In our last class, we talk about geometric progression, talk about the sum of geometric series and the nth term of the geometric series. So if you still remember right, the sum of the nth term of the geometric series is given by the formula was a in brackets was r raised to power n minus 1 over what? R minus 1 for what? R greater than 1. Then we also talk about this formula 1 minus r raised to power n over what? 1 minus r or what? R less than 1. Now, in today's class, we'll talk about sum to infinity. Sum to infinity. Sum to infinity. Talk about sum to infinity in a geometric series. Now, let's look at this. Let's look at this geometric series. I have 12 plus 6 plus 3 plus 3 over 2 plus 3 over 4 plus it goes on and on, right? Now, if you look at this geometric series, we notice that what? Our R in this case is what? 6 divided by 12 is what? 1 over 2. If you take this also, 3 divided by 6 is also 1 over 2. Our common ratio in this case is what? Is 1 over 2. So now let's take the sum to 10th term. The sum of the first 10 terms of this series. The sum of the first 10 terms. In this case, A is what? A is 12, right? So the sum of the first 10 terms, I have what? A in brackets, what? Which is 12. In brackets, R. Our R is what? 1 over 2. Okay. R is less than 1. So we won't use this formula. We use this formula, right? So I have 12 in brackets, what? 1 minus 1 over 2 raised to power what? Raised to power 10. And over 1 minus 1 over 2. So now, let's take the 10th power of 1 over 2 and see what we get. 1 over 2 raised to power 10. I have 1 over 2 all raised to the power of 10. It gives us what? 0.000. You notice this gives us 0.000976563. Now, let's assume we are asked the sum of the first 20th time. Sum of the first 20 term. 20. In this case, the power will be what? Raised to power 20, right? Let's take raised to power 20 and see what we get. We have more zeros, right? We have 0.1 over 2 raised to power 20. I have what? 0. What? 0.0000954. If you go further, take the 50th term. Sum of the first 50th term. S50. I have what? 1 over 2 raised to power what? 50 Abi. If you take that, 1 over 2 raised to power 50. I have what? More zeros behind this. I have 8 times 8 times 10 raised to power what? Minus 16. So what did we notice? We noticed that what? As the sum of the nth term is what? It's getting more and more. As it's increasing, notice that this what? This value here is approaching what? 0. Abi. 8.88 times 10 raised to power minus 16. You have what? 0.00000. It's approaching what? 0. That tells us that what? As r raised to power n is what? Is 0 as what? N tends to what? Infinity. As this one is going higher, 100, some of the first 100 times, some of the first 1,000 times. So you keep approaching what? 0 as this n is going what? Higher and higher. So that's when sum to infinity comes in. That's when sum to infinity comes in. Sum to infinity simply tells us that what? The the sum of the what? Infinite term, Abi, as S infinity to give us what? We have what? A in brackets 1 minus r raised to power n. Now, remember, as n is approaching infinity, instead of me writing n here, I put infinity. R raised to power n what? Tends to 0. So I have what? 1 minus what? 0. Do you get it now? So I have something like this. A in brackets 1 minus what? 0 over what? 1 minus r. 1 minus r. That tells us that what, as this n here is approaching what, infinity, our r raised to power n is approaching what, 0. Do we get it now? R raised to power n is up. So that tells us the sum to infinity is given by this formula. A in brackets 1 is what? A over what? 1 minus n. So this is the formula for the sum to infinity. So now you might be asked in a question, calculate the sum to infinity of a geometric series. So of a geometric series, given the first term and the what? The common ratio, we simply use this what? This formula. Do we get it now? So that's the formula for the what? The sum of infinity. But we are asked calculate the sum of the nth term, either 10th term, 20th term, the first 20th term, we simply use this formula. And mind you, we need to get our R to know which of these two formulas we use. If its R is less than 1, we use this second one. If R is greater than 1, we use this first one. And we get our answer. So this is the formula for the sum to infinity. So let's take questions on it. Okay, now let's take question 19 from page 20 in your position. Question 19, page 12. Question 19, page 12, sorry. So now, looking at the question asks us, find the sum to infinity of the following geometrical series, geometric series. Find the sum to infinity. So we are given the series 3 plus 2 plus 4 over 3 plus 8 over 9 plus 16 over 27. Goes on and on, to infinity. So now we have to calculate the sum to infinity in this term. We get our what? Our first term according to the formula A. In this case, A equals what? The 3, the first term here is equals to 3. Now let's get the common ratio, R. The common ratio R is just simply your second term divided by the first term. So I have what? I have 3 and 2 over 3. You can also pick another one. If you pick 4 over 3 divided by 2, you have the same thing. 4 over 3 divided by 2, which is simply what? 4 over 3 times 1 over 2. I still have what? The same 2 over 3, right? So now, the question is asking us, find the sum to infinity. The sum to infinity is what? S infinity, abi? Now, let me mind you, doesn't matter if your R is greater than 1 or less than 1, you use this formula whenever you ask the sum to infinity. You get it now. But in most cases, it's always less than 1. So the denominator here will be what's positive, abi? So now let's do the sum to infinity. I have what? 3, which is our A, 1 minus what? 2 over 3. So let's get that. Answer is what? So this should give me 1 over 3, right? So if I bring this up, I should have what? 3 times 3, which is what? Which is 9, right? So that tells us the answer is what? Option B, which is what? Which is 9. So let's take another question. Let's take another question on that. Let's take look page 54, number 77. Let's look at the question. So I'll clean this. So calculate the sum of an infinite term of an infinite geometric progression is 2/2/7. So according to the question, let's interpret this. The sum of what? Of an infinite term, infinite geometric progression. This sum to infinite, this infinite. So is equals to what? 2/2/7. Abi? Turn into your mix and your improper fraction. I have what? I have 16/7. So now we are told the first term is what? The first term is what? Is 4. What is the what? The common ratio. Very simple. Using this formula, Abi. So I have what? My sum to infinity is what? 6. 16 over what? Over 7. And I have what? A is what? 4 over what? 1 minus what? R. Then I asked to get the what? The R, Abi, the unknown. So we cross multiply. 16, 1 minus R when you cross multiply. Then you have what? 7 times 4. So I simply have 16 minus what? 16R. 7 times 4 is what? That should give me 28, right? So now, collecting like terms, I have what? 16 minus 28 equals what? Equals 16R. So 16 minus 28 is what? We are subtracting what? A smaller value from a what? From an higher value. Then definitely we have a what? A negative, right? So 28 minus 16 or 16 minus 28 should give me what? That's what? That's 12, probably. So I have what? Minus 12 equals what? 16. I divide both sides by what? 16. So that tells me my R is what? Negative, but you can divide both sides by 4, have you? Up and down. So I have what? 3/4. So in this case, my R is what? Is option B, minus 3/4, which is the answer for the common ratio in this case. So whenever we are asked to calculate the sum to infinity, definitely we are not expecting them to tell us n, Abi, because n is always what? N is what? Infinity, Abi. Does not have any end. So whenever you are asked to calculate the sum to infinity, just know you have business with your first term and the common ratio. So let's take okay, so let's attempt this. It's a class exercise. Page 56, question number 98. Question 98. As you can see it on your screen, the nth term of a sequence is given by un equals 2 plus 3 un minus 1 u subscript n minus 1 while u4 plus 36 plus u3. Find the third term of the sequence. Find the third term of the sequence. Okay. You guys have been okay, so I need answers. Answers can start coming. Question number 98. Are you guys there with me? The answers. I need answer. The question is not relating to sum to infinity, but it's on that geometric series. Just your GP and arithmetic AP. So let's solve that and see what we get. Okay, I'm waiting for answers. Okay, answers. What are the answers? Let's be quick about that. I need to know I'm not yet, So what's your answers? Your answer. You can attempt it. Your answer. Anyone? Answers. Okay. No answers. Let's attempt this together. So now, according to the question, we are told what the nth term of a sequence is given by what? un equals what? 2 plus 3 u subscript n minus 1. What does this mean? That tells us that what? The nth term of this sequence is simply what? 2 plus what? 3. Then this is the what? The previous term. If this is the third term of the sequence, it should just be what? 2 plus 3 u was subscript 2, which is the second term. Now, we need to what act according to the question. We are told why what u4. We are given what u4 specifically, Abi. U4 equals what 36 plus what u3, Abi. We are given u4, which is what the fourth term to be what 36 plus what plus u3. So now what will we do? Just substitute your what your first term into this equation here. This is like the general equation. Just substitute it into this equation here, right? So now, what will u4 here be? U4 equals what? 2 plus what? 3 u4 minus 1, Abi. Obviously, 4 minus 1 is what? 3. U subscript 3, Abi. The first term is equals to what? 2 plus what? 3 u3, which is your third term. Now, just equate these two together, Abi. We are given this one from the question, right? We got this from the what? From the formula by substituting what? U subscript 4. So by the time we equate these two together, I have what? 36 plus u3 is equals to what? 2 plus u3 u3, Abi. Both are what the first term of the sequence, Abi. Now let's equate it together to get the third term. Mind you, the question is asking us for what? Find the third term of this sequence, which is what u3, Abi. So collecting like times, I have what 36 minus 2 equals what 3u3 minus what u3, Abi. So this gives me what 34 equals what 2u3. I divide both sides by what? By 2. So I have my what? U3 to be what? 17. That tells me that what? The third term for this sequence is equal to what? To the 17. To 17. So that tells us the answer is option C, which is what? Which is 17. Option C. That's the answer. So let's do the next question. Let's treat another question. Page 122, question number 99. So 39, question 39. That's just on what we've been doing so far. We have to calculate the sum of what? Infinite progression. And we're given the series. So now let's attempt that. Then I will ask you guys questions so far. If you get what I've been saying, you can ask your questions after doing that. So now the question he asks us that what? Find the sum of what? Of the infinite progression. That tells us what? S infinite, which is what? A 1 minus R. So the first term in this series is what? 1 over 2. You can see it here, 1 over 2. And over what? 1 minus. Now, where is the series? This is the series, 1 over 2, 1 over 4, 1 over 8. Obviously, we have to calculate R, right? And my R is just what? 1 over 4 divided by what? 1 over 2. So I have 1 over 4 times what? 2 over 1, which is what? 1 over 2. So this is my what? Common ratio. So I have this as common ratio. So now 1 minus half is just what? I have half over what? Half. And half over half is what? 1. So that's what? That's option A. That's option A. So do we get that? Option A. Okay, so now let's explain this again. Let me explain this again. I have what? Find the sum of what? Of the infinite progression, right? Find the sum of the infinite progression. I'm in the series, I'm giving what? The first term to be what? 1 over 2. Second term, 1 over 4. The third term, 1 over 8. Now, whenever you are asked to calculate the sum to infinity, you know, if you remember this formula, we have what? We have our first term over what? 1 minus the common ratio. That tells us that what? In whatever we do, we need to calculate what's the common ratio. We must always plan to calculate the common ratio. And if you remember right, your common ratio is always what? The second term over what? The first term. Or what? The third term over what? The second term. Doesn't matter which one you use. Or what? The first term over what? The third term. Now let's pick the second term. The second term in this case is what? 1 over 4, right? So I have what? 1 over 4, Abi, divided by what? 1 over 2. Mind you, I'm still trying to calculate what? My R. So I can input it in this formula. So now I have what? 1 over 4 divided by what? 1 over 2, which is simply what? 1 over 4 times what? 2 over 1, Abi. So now if you cut it, you have what? 1 over 2. Do you get it now? So that tells us that what? My common ratio in this case is what? 1 over 2. So I will just input it in this formula. The first term is what? 1 over 2. 1 over 2, right? Over 1 minus, what is the common ratio? 1 over 2, Abi. Can we notice our common ratio is also what? 1 over 2, which is this 1 over 2 here, Abi. So now if you subtract 1 from an half, you have what? An half, Abi. So which is, then you have your 1 over 2. So your 1 over 2 cancel 1 over 2, obviously. So my answer is what? 1. So that tells me that what? The sum to infinity of this series is what? Is 1. Do you get it now? So that's it. Any question? Any question? Before we've done so far, which part do you not get? Which part do you have issue with? Let's do that. Questions can start coming. Any questions? Okay, you guys have been unmuted. Can ask your questions now. Questions can start coming. Since from what we've done so far, something infinite. You have just 1 minute. Okay. Any question? Any question? Any parts you not get? Anyone that is confusing you? Anyone can just ask questions on that. So any questions so far? On anything, arithmetic progression, geometric progression, sum to infinity, sum of arithmetic progression, sum of geometric progression, geometric mean, arithmetic mean. All we've done so far under what sequence and series. Your question can come in. Do you have any issue with that? Any question? All right. No question. Any question? Okay, no question. Okay. Now let's yeah. Speak loud. I can't hear you. What's the question? Okay, no question. Now let's move to the next topic. Now we are done with anything relating to arithmetic and geometric series. Now let's move to what is called measure of central tendency. Measure of central tendency. And in this case, I'm talking about what? Mean, median, and mode, right? Mean, median, and mode. So I'll just do a brief explanation, a brief introduction to this. So now, what do I mean by mean? If you are asked, calculate the mean of these numbers, of this following set of numbers. Can I be given any random number? Can I be given 3, 2, 1, 4, 6, 9, 11, 13. Let's say 14, Abby. Let's just pick. Let's pick 18. So I have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I'm asked, calculate the mean of this following set of numbers. Mean is just simply what you know as average, Abby. Mean also known as average. It's just the sum of what? All these numbers divided by what? By the total number. Mean also known as what? Arithmetic mean. It's just simply what? Sum of all numbers divided by the what? The total number. So I have what? 3. In this case, Abby, plus 2, plus 1, plus 4, plus 6, plus what? 9, plus 11, plus 13, plus 18, right? And how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus divided by 9. So that gives me what's the mean of this number, of this set of numbers. So let's do that. So, okay, you get the answer for that, right? Now let's do. So you attempt this, get back to me on this. Now let's move to what? Let's move to median. If you are asked, what is the median of this set of number? Originally, I know my median is just what? The middle number, right? The median is simply the middle number of these numbers, right? But whenever you are asked to get the median, you have to what? To arrange those numbers in ascending order. When I say ascending number, I mean from the what? From the smallest to the what? To the biggest. So starting here, 1, 2, 3, 4, 6, 9, 11, 13, 18. From the smallest to the what? To the biggest, right? So what is my median? The middle number. What's the middle number? Cancel this one out, cancel this one out. Can get your middle number from that. So my middle number in this case is what? Is 6. That tells me my what? My median is 6. Now, let me tell you guys one thing. If the total number, if the numbers here are what? Are 10 instead of what? Of 9. Let's assume I have one more number, 19. And I'm asked, calculate the median. Obviously, if you know, when we start canceling out these numbers, after arranging it, let me arrange it here. We start canceling out 1, cancel out 2, cancel out 3, 4. I'm left with what? 2 numbers, right? So if I'm asked, calculate the mean of the median of this number. It's simply what? 6 plus 9 divided by 2. So what I'm telling you guys is just that what? By the time you start canceling out the numbers and you are left with what? 2 middle number, The two new number, for you to get the median, just simply was add both of them divided by what? Divided by 2. You get your median from there. So now the last one is what? The mode. The mode of the numbers. Now, what is the mode? Mode is just simply what? The highest what? Occurring number, the one that what? That happens to what? Occur most. Now, let's look at these numbers. I have 1, 2, 2, 3, 4, 4, 4, 9, 9. So if I'm asked, what is the mode of this number? Remember, the number that appears the most. So in this case, 1 is just once. 2 appears what? 2 times. Even in this case, appears just once. 4 appears how many times? 3 times. Then 9 appears what? Twice. So now, what is my mode for this set of numbers? My mode is simply what? 4, which is the number that appear most every. So that's just a brief explanation on on the arithmetic mean, the median, and the mode. Your arithmetic mean is simply the average of the set of numbers. You add the numbers together divided by the total number. Then the median is just what? Your middle number. But you don't just get your middle number, you have to to arrange them in an ascending order. So I have what? I have my answer here. Now my mode is the one that appears frequently, that appears the most. I have my what? I have my answer. So for this, if you have to calculate the mean, what's my answer here? After calculating, what's the answer? You guys have been unmuted. What's the answer?
7 point.
Yes?